In asymmetric routing, data packets take one path to reach their destination and a different path on their way back. This may not sound like a big deal, but it can lead to issues when stateful firewalls are part of the network path. In this episode of Cisco Tech Talk, I'll explain asymmetric routing, some issues it can cause, and how to reconfigure your network to prevent it. Next. A firewall with stateful packet inspection looks closely at the first packet of data when it starts a new connection. It remembers this information and keeps track of the conversation or flow. If a packet comes in and it's part of the conversation the firewall remembers, it lets it through. Conversely, if the packet does not match or is not associated with an existing flow, it is dropped. Protocols that maintain state information, such as HTTP and TCP, may be affected by asymmetric routing, while stateless protocols, such as ICMP, may not. To illustrate the impact of asymmetric routing, consider the following network diagram. In this network, there is a layer 3 switch and a firewall with stateful packet inspection capabilities connected via a trunk link. The switch has two connected devices, a PC and a server, each belonging to different VLANs and subnets. The firewall serves as the default gateway for the PC, while the layer 3 switch is the default gateway for the server. When the PC attempts to initiate a three-way TCP handshake with the server, it sends a TCP SYN packet to its default gateway, the firewall. The firewall then forwards the packet to the server. In response, the server sends a SYN-ACK message, which is directed to its default gateway, the layer 3 switch. The layer 3 switch consults its forwarding table and finds that the PC's VLAN is directly connected, so it forwards the SYN-ACK message directly to the PC. The PC then attempts to complete the handshake by sending a TCP ACK message back to the server through the firewall, its default gateway. However, the firewall performing stateful packet inspection drops this ACK packet because it did not see the SYN-ACK coming from the server and therefore has no established flow state for this connection. In practice, to demonstrate this behavior, a layer 3 switch could be connected to an RV345 router with firewall capabilities that include stateful inspection. For example, two IPv4 interfaces on the switch could be set up for VLAN 1 and VLAN 2, with corresponding interfaces configured on the router. The router and switch would be connected via a trunk link. A PC might be connected to an access port on the switch that is a member of VLAN 2, with a static IP address configured and the firewall's IP address in VLAN 2 set as its default gateway. A server with an IP address in VLAN 1 might also be connected. In this setup, while the server responds to ping requests, attempts to access it through other protocols may fail. Checking the firewall logs would reveal that the firewall is dropping the TCP ACK messages from the PC. To resolve this, a few reconfigurations are needed on the network. Set up the firewall or the switch as the default gateway for both the server and the PC. In this example, by changing the default gateway on the PC to the IP address of the layer 3 switch within VLAN 2, the asymmetric routing issue will be resolved. There you have it, the basics of asymmetric routing and how to prevent it in your network. Thanks for watching. I'll see you next time.